Okay, so good morning once again. So I'm here to discuss the difference between t-test one sample and z-test one sample. Okay, both tests are used to determine differences between population mean and sample mean. Okay, so that's one of their similarity. Ang difference nila, okay, based on the sample size. Pag sinabi nating z-test one sample, this is used for sample size greater than or equal to 30. Okay, greater than or equal to 30. So therefore, pag naging less than 30 na siya, ang gagamitin na natin is t-test one sample. Another usage ng z-test one sample, if your population standard deviation is given. Okay, so that means sa t-test one sample, hindi given ang population standard deviation. Instead, ang given is the sample standard deviation. Okay? Okay, so under z-test one sample, in the event that sample size is greater than 30 and population standard deviation is not given, then you can use the sample standard deviation to estimate your population standard deviation. Okay, so kunwari nagkataon, magko-compute tayo ng, kasi we need the standard deviation in the computation of your computed value sa z-test one sample. Nagkataon na greater than 30 yung sample, pero hindi given ang population standard deviation. Pero ang given sa problem is the sample standard deviation. You can actually use the sample standard deviation in replace to replace the value of your population standard deviation or to estimate the value of your population standard deviation. Okay, so take note of this. Gagamitin lang natin ng z-test one sample if we satisfy either A or B. So isa lang dito sa A or B ang kailangan nating masatisfy. Either sample size is greater than 30 or equal to 30 or population standard deviation is given. Whereas sa t-test one sample, kailangan natin masatisfy both A and B. Okay, so ibig sabihin, to use t-test one sample, your sample size should be less than 30 and sample standard deviation is given. Okay, so these are the formulas of your z-test and t-test one sample. So if you look at the formula, halos pareho lang siya. Okay, halos pareho lang siya. Nagkakaiba lang tayo dun sa notation ng standard deviation. Okay, dito, ang standard deviation dito is yung notation ng population standard deviation, whereas dito po, ang notation na ginamit natin is the notation for sample standard deviation. Okay, and then halos pareho lang yan. Your X bar here, this is the value of your variable. Usually, that is given in the problem. Your mu here, okay, is your population mean, your mu. Of course, over ito, yung standard deviation, this is the standard deviation over square root of n. Your n is the number of sample size. Okay, so let's go back to your hypothesis testing na steps. So, di ba ito yung steps natin? We formulate first your HO, HA, we determine your statistical method, we determine the decision rule, the computation, the values, computed and tabulated or critical, and then the decision, and then conclusion, whether to reject or accept HO. Okay, so ano-ano ba yung mga laman nito? Kasi baka I've mentioned some of the technical terms tapos medyo nawawala na tayo. Okay, so para mas maintindihan natin hypothesis testing, I'll be giving examples for z-test one sample and t-test one sample. Okay, so I'll start with z-test one sample. Okay, so since yung naging focus natin last time sa discussion is formulating your HO saka HA, okay, dito sa z-test one sample, I want you to take note of this possible alternative hypothesis. Ito, di ba? Ito yung HA natin. Sa HA natin, di ba, there are three possible hypotheses. Pwedeng not equal, pwedeng less than, pwedeng greater than. Okay, pag nag-conduct tayo ng test of hypothesis, meron tong mga corresponding decision rule. Okay, pag yung alternative natin is not equal, this will be our corresponding decision rule. So, kokopyahin lang po natin tong decision rule na to. Pag letter B naman, we're in less than, of course, this will be our corresponding decision rule. Take note, yung Z sub C po, that is your computed value. And then itong may Z na may alpha, this is our tabulated or critical. Okay. So usually po, ini pong mga tabulated or critical value, this is already given in a table. Okay, ito. So given na siya, titingin na lang po tayo dito. Instead of looking at our Z table, I provided the tabulated or critical. Okay? So let's go back. So take note of this. Let's go back to, so kung letter A po, kung ang alternative hypothesis natin is not equal, so this is the corresponding decision rule, take note of the absolute value ng Z sub C or the computed value. Pag sinabi po natin absolute value, so just in case ang makompute natin na Z sub C is negative, we get the absolute value of that, magiging po siyang positive. Okay, so always positive. Pagdating naman po dito sa letter B, if your alternative hypothesis is less than, then this will be our decision rule. Reject HO if Z sub C is less than the negative. So kung ano man po yung makuha natin na tabulated or critical, you get the negative of that. Gawin nyo siyang negative always. Okay? If your alternative is negative, less than. Okay. And then thirdly, if your alternative is greater than, again, we copy this as your decision rule. So reject HO if Z sub C is greater than Z alpha, otherwise accept HO. Okay, so yung Z sub C is your computed value, your Z alpha is your critical or tabulated value. So again, for the critical or tabulated value, this is already provided. So titingin na lang tayo dito. Okay, so para mas maintindihan natin yung Z-test one sample, let's have this example. Okay, so the weight of crabs is normally distributed with mean 28.5 ounces and standard deviation of 3 ounces. I want you to take note of the first sentence. Dito class of first sentence, ang mean na 28.5, this is already our population standard, population mean. Okay, population mean 28.5 and standard deviation of 3 ounces. This is our population standard deviation. Okay. Next statement. A new breeder claims that he can breed crabs yielding a mean weight of more than 28.5. Okay, so ito yung kiniklaim niya or ito yung parang ipoprove natin dun sa study na to. A new breeder claims that he can breed crabs yielding a mean weight of more than 28.5. Okay, let's apply this in a particular scenario. For example, you're a restaurant owner, okay? And then ang sinuserve mo mga seafoods. Okay, so meron ka ng kinukuhanan ng supply. May nagsusupply na sa'yo ng crabs, okay, na nagbibigay ng bigat na 28, on the average 28.5 ounces. Okay, then comes this new seller na nag-o-offer sa inyo ng, kunwari na may dumating, may nag-drop, may nagbisita sa restaurant mo, nagsabi siya na, sa akin ka na lang kumuha ng mga crabs kasi ang mga pinoproduce kong crabs mas malalaki kaysa yung mga kinukuhanan mo. Okay? So, dinalhan siya ngayon ng 16 crabs. So, a random sample of 16 crabs from the new breeder had a mean weight of 29.2. So, nagpakitang gilat siya sa'yo. May dala-dala siyang 16 samples ng crabs niya. And then sabi niya, sige nga, i-weigh mo, tingnan natin weight kasi talaga mas malaki to. So, ang lumabas is 29.2. Numerically, mas malaki talaga siya. Mas mabigat siya dun sa kinukuhanan mo. Pero, dapat natin malaman kung statistically ba talagang higher siya doon sa nagsusupply sa iyo ng crabs. Okay? Okay. Kasi pwedeng pag sinabi natin statistically higher, ibig sabihin malalaki talaga yung mga crabs niya. Okay? So you have enough basis para magbago ng supplier. Pero pag ang lumabas sa statistical test natin is walang significant difference, ibig sabihin nagkataon lang na mabibigat or malalaki yung mga crabs na dinala niya. Pwedeng gusto niya lang magpakita ang gilas, so ang mga kinuha niya yung mga malalaking crabs. Pero sa totoo, hindi ganun kalalaki yung mga crabs niya. Okay, so that's what we want to find out in this particular test. So sabi dito, at 5% level of significance to the data support the breeder's claim, ang 5% po dito, this is our alpha or level of significance. Anong importance nito? Or how do we interpret this? Ang 5%, that is the probability of error. Okay, so whatever conclusion na ibibigay natin dito sa study na to, we are just giving conclusion that is 95% correct or 95% accurate. Kasi nga nanggaling, ang pinagbasihan lang naman natin is sample data. Okay, so that's your alpha or level of significance. Okay, so what will be our test of hypothesis? Ayan, so we start with the weight of crabs is equal to 28.5. Diba? Ito yung napag-aralan natin sa pag-formulate ng null and alternative. So palagi nating i-equate siya dun sa population mean. Okay? So ano yung mini-measure dito sa problem na to? It's the weight of the crabs. Always equate to the population mean. So equal to 28.5. Okay. Alternative would be the weight of the crabs is more than 28.5. Again, population mean na, hindi yung sample mean. More than 28. Bakit more than 28? Kasi sabi dito sa second statement, a new breeder claims that he can breed crabs yielding a mean weight of more than. Okay, so this will also be our alternative hypothesis. Okay, take note of your alternative. Diba? It's greater than. So ito po yung decision rule na ginamit natin. Okay? So balikan natin, 'di ba? Pag greater than. Okay, sabi dito, pag greater than, which is letter C, iniman po ang kokopyahon mong decision rule. Okay, so just copy. Okay, let's go back to the problem. Ayan. So alternative hypothesis, decision rule. And then statistical method is z-test one sample. Okay, bakit z-test one sample? Tingnan nga natin yung sample size. Sample size is not greater than 30, it's less than 16 crabs. But ang given dito is the population standard deviation na 3 ounces. So ang kailangan lang naman natin i-satisfy dun sa z-test is either yung sa sample size greater than 30 or given ang population standard deviation. So we have satisfied the second criteria. Okay, so that's why the appropriate test for this is the z-test one sample. Okay, so for the computation part, dito lang naman class sa formula natin ng z sub c or computed, isa-substitute nyo lang yung value. Okay, so 29.2 dito sa variable, okay, substitute mo yung 29.2 minus 28.5, that's your population mean. So take note palagi mo ima-minus yung population mean. Hindi pwedeng mainot si population mean dun sa variable. Okay, so mauna yung variable minus the population mean. Okay, over standard deviation is 3 over the square root of 16, which is the sample size. So ang lumabas na z computed is 0.933. Okay, ang z alpha natin or z tabulator or critical is 1.64. Bakit 1.64? Kasi ang alpha natin is 5%, tapos we have a one-tailed test. Okay, so 5%, tapos one-tailed test. Yan. So kinopya natin yung 1.64. Okay, so i-compare natin ngayon. Sabi dito sa decision rule, reject HO kung mas malaki ang Z computed sa Z alpha or tabulated. Okay, mas malaki ba ang 0.933 sa 1.64? Hindi. Okay, so since Z sub C is less than Z alpha, hindi natin i-reject but we accept HO. Okay, so don't be confused. I-reject lang natin if Z sub C is greater than Z alpha. Okay, so we accept HO because it's less than. So this should be less than. Yan, less than to dapat. Sorry. Yan, less than. Kaya accept HO. Okay, when you accept HO, go back to your HO. Literally, kukopyahon nindo ang HO nindo. Kasi nga, accept HO. So you start your conclusion by mentioning the level of significance always. So you say, at 5% level of significance, it can be concluded that the mean weight of the crabs is equal to 28.5. Thus, okay, this should be you. Thus, there is no enough evidence to support the breeder's claim. Okay, so ibig sabihin, nagpakitang gilas lang sa inyo yung bagong supplier. Hindi naman talaga ganon kalalaki yung mga crabs niya. So there is very useful when it comes to decision making pagdating sa business. Okay? So let's move to t-test one sample. Okay, so sa t-test one sample naman, pareho din, meron din tayong alternative saka may corresponding decision rule. So dito sa alternative, ganun ulit, pwedeng not equal, pwedeng less than, pwedeng greater than. Again, may mga corresponding siyang decision rule. So you just have to copy. Okay, pag not equal, ito yung magiging decision rule natin. Take note, hindi na Z sub C. So gagamit tayo ng ibang table this time, which is the T table na pre-provide ko na sa Google Classroom natin. So pag not equal daw absolute value ng T sub C, okay, greater than, so take note of this subscript. Kung ano mo yung alpha ninyo, is so divide nyo sa 2, tapos n minus 1. This is the number of samples. Okay? Pag less than naman, this will be our decision rule. Again, pag naka-less than, kung ano yung makukuha natin na value sa table, you get the negative of that. And then, pag greater than, again, we copy this corresponding decision rule. Okay, let's start. So this is the T table. Okay, sa first column, may makikita ka yung parang V. This is equivalent to n minus 1. Okay, n minus 1. Okay, so let's have the problem. So a soft drink vending machine is set to dispense 6 ounces per cup. Okay? So itong 6 ounces class, this is your population standard mean. Take note walang binigay na population standard deviation. It is just your population standard mean, population mean. Okay, next statement. If the machine is tested 8 times, yielding a mean cup fill of 5.8 ounces with a standard deviation of 0.16, okay, tinest ng 8 times, this will be your N or sample size. Okay? So, ang N natin could be the sample size or number of trials or number of experiments. Okay, so nag-agree sa akin yun, manok namin. Okay, so the sample mean is 5.8 with a standard deviation of 0.16. Your 0.16 here is your sample standard deviation. Okay, so is there evidence at 5% level of significance that the machine is underfilling cups? Assume normality. Okay, what will be our test of hypothesis? Okay, HO would be the machine dispenses 6 ounces per cup. Okay, so inequate lang natin dun sa population mean. Alternative natin is the machine dispenses less than. Okay, bakit kaya less than? Okay, what gave us an idea na less than 6 ounces? Okay, so going back to the problem, ito actually yung keyword natin na nagbigay sa atin ng idea na less than 6 ounces. Sabi kasi dito, the machine is underfilling. Ibig sabihin, kulang yun, pinupuno nyo dun sa cup. So, we have less than. Okay? So, since less than yung alternative hypothesis, ito po yung kokopyahin natin na decision rule. Okay? May corresponding decision. So, take note, reject HO if T sub C is less than the negative, kung ano man yung makukuha natin sa table. Okay? So, let's compute for the T sub C or the computed value. Again, substitute lang natin. Sample mean minus the population mean over the sample standard deviation over square root of 8, which is your sample size. Ang lumabas is negative 3.536. Okay, so let's obtain the value in our table. So sabi dito is alpha is 0.05, n minus 1, n is 8, so minus 1 is 7. So hanapin natin yung 0.05 tapos 7. So going back to the table, okay, 0.05, okay, ito yon, and then 7. Okay, ito po yon. So kunin nyo lang yung intersection ng dalawa. So intersection niya would be, okay, this one, it's 1.895. And sabi dito, negative of that. Okay, so you get the negative of that. So magiging negative 1.895. Kukunin nyo lang class yung negative kung ang alternative hypothesis natin is less than. Okay, so please don't forget. Okay, let's go to the decision part. So since negative 3.536 is less than negative 1.895, we reject HO. Okay, di ba? Balik tayo sa decision rule. Sabi, reject HO if T sub C is less than the negative. So, ang value naman ng T sub C, which is negative 3.536, is less than negative 1.895. So, our decision is to reject HO. Okay, let's go to conclusion. When you say reject HO, okay, literally, i-reject mo ang HO. Ang gagawin mong conclusion, si HA. Kasi nga, ni-reject mo yung HO. So, kukopyahin nyo lang class yung HA, but you start your statement by mentioning the level of significance. So, palaging ganon. You always start by mentioning the level of significance. So, you say, at 5% level of significance, it can be concluded that the machine dispenses less than 6 ounces, thus it is underfilling the cups. Okay, so that's it. So hopefully nakita natin yung difference ng z-test 1 sample and t-test 1 sample with the examples given. So thank you very much for listening and watching.